Welcome to Study Loop.
Okay, so rational functions, that first question does not really make sense to me, so I'm going to move on to number 2. How can you determine non-permissible values from the graph? Well, non-permissible values are going to show up as vertical asymptotes. So you will know where you have a 0 in your denominator. And then also they can show up as holes on the graph. And number 3, we want to know from the equation, how can you tell whether you have an asymptote or a hole? Okay, so I'm going to make up an example of a function. Put x plus 3 over, and I'm going to call that x plus 4, x plus 3. Okay, so I have 2 non-permissible values. I have x equals -4 and x equals -3. Now, -4 is going to be a vertical asymptote. And I know that because it's what we call not removable. At -3, you are going to have a hole. And that's because -3 comes from this x plus 3, which can be canceled. So canceled factors produce holes. Non-cancelable factors produce vertical asymptotes. Horizontal asymptotes, if you have an equation, happen if the degree of the numerator is less than the degree of the denominator, or if the degree of the numerator equals the degree of the denominator. Let me just give you an example of each of those. So let's say I have 3x over x squared minus 1. That's an example of the first case. I'm going to have a horizontal asymptote at y equals 0. Now, if my degrees are equal, let's say I have 3x squared over x squared minus 1. Now I'm going to have a horizontal asymptote at 3. So in number 5, let's just do this last one. So number 5, I'll put over here. Determine an equation for a rational function whose graph lies on a horizontal line and has exactly 2 non-permissible, not sure what that means, lies on a horizontal line. I'm going to say has a horizontal asymptote and has exactly 2 non-permissible values. So 2 non-permissible values could be just like what we saw up here. You could have x plus 3 over x plus 4 times x plus 3. And again, you're going to have 2 non-permissible values, -4 and -3. One will be a vertical asymptote, one will be a hole, and you will have so let me just write that. You're going to have a vertical asymptote at x equals -4. You're going to have a hole at x equals -3. And you're going to have a horizontal asymptote because your degree is smaller on top at y equals 0.